For this lesson, we will be looking at the RGB LED. The RGB LED is a component that has 3 LEDs inside of it. There is a red LED, a green LED, and a blue LED in a semi-transparent plastic housing. When we vary the voltages to the red, green, or blue LED, we can get a significant change in the colors. Let's look at the schematic and identify some of the components that we find on this RGB LED module. First of all, we have the pins. We have a VCC pin, which we will be providing power to the LEDs. We have the R pin, which changes the red LED. We have the G pin, which changes the green LED. And we have the B pin, which changes the blue LED. We also have 3 resistors. These resistors are 330 ohms. The resistors provide protection for the LED to ensure that there is not too much current flowing through the LED. In order to ensure that we understand how this RGB LED module works, we are going to plug it into our GPIO extension board and check each individual LED circuit to make sure that we understand how this is going to be set up. So get your RGB LED module out, and you'll also need a 4-pin connector. The first circuit that we will be testing on our RGB LED module is the red circuit. So the red circuit, we are going to turn on the red LED, and the way that we are going to do that is we will connect the VCC pin, the brown wire, into the 5 volts found at physical pin number 2 on the GPIO extension board. The next thing that we'll do to simply turn on the LED is take the R pin, which is the white wire, and we will plug it into a ground pin. In my example, I have plugged it into physical pin number 9 on the GPIO extension board. You should see your LED illuminate red. Now let's do the same thing with the G circuit so that we can illuminate our green LED. We will leave the VCC plugged into the 5-volt source at pin 2, and we will take the G pin, which is the red wire, and plug it into a ground, and the ground that I've selected is the physical pin ground number 9. You should now see that your LED has changed. We've now turned the LED green. Alright, why don't you take a few minutes, go ahead and pause the video, and see if you can figure out how to turn on just the blue LED on our RGB LED. Hopefully you took a chance to pause the video and try this yourself. You should have plugged the VCC into the 5-volt at pin number 2, and you should have plugged your B pin, which is the black wire, into a ground. I plugged mine into the ground at pin 9. Let's see what will happen when we plug in 2 of the LEDs at the same time. So let's take our VCC and connect it to the 5-volt at pin number 2. And we will plug our red pin, which is the white wire, into a ground. I've picked ground at pin 9. Let's plug our G pin, which is the red wire, into a ground. I picked physical location number 25. So we get a color that is kind of green. At least it looks green on the screen. On your bulb, it'll probably look a little more yellow The combination of full red and full green will give us a yellow color. Let's see what happens when we do a full red, green, and blue. In order to have all the circuits powered on, I just need to connect the B pin, which is the black wire, to ground, and I'm just going to connect it at location pin number 39. And now we see that the LED has turned to white. Now, because of the quality of this LED, you may or may not see the individual LEDs as they're not blended in a perfect way, but this LED is a representation of a pixel. So we will stop the video here, and we're going to watch several videos that discuss the pixel and what it means to us. All right, hopefully that video or set of videos was helpful in showing you how a pixel works. So our LED is similar to a pixel. It's a lot larger and the quality isn't the best, and so that's probably why we see the blending isn't as good. Plus it's a lot larger than a pixel would be. So here I have an RGB Color Picker. So I just put that in Google and I get this widget here at the top. So this can help me to understand the many different combinations of red, green, and blue that I can utilize to get 16,770,000 different color combinations. So we did this electrically when we connected up our LED. We connected the red to ground, and red already had full power, and we connected the green to ground, and so both of those were at the highest representation, which is 256. The reason the number is 255 is because we are counting 0 as a number. So 255 is 100% on for the red, and 255 is 100% on for the green. 0 means that the blue was off. And so here we see that the color that should be represented when we turn on red and green is yellow. So when we start to change the combination, we can come into this color picker and I can actually make a change here. So if I change this directly to 0, then I get a full green. When I change them all to 0, I get a black color, and when I change them all to 255, and you can drag it around as well, so here's 255, and the 255 then becomes a white. And so it's fairly easy for us to see that if I wanted to get a white LED, and we did this with our first setup, we need to turn red all the way on, green all the way on, and blue all the way on. So that was a fairly easy one to represent. As we just demonstrated, yellow was fairly easy to represent, right? And of course, red by itself, or green by itself, or blue by itself is fairly easy to represent. But what if I wanted to have that color right there? How do I change the red value to 126? How do I change the blue value to 145? And so we're going to set up this RGB and pass it the numbers that are not all the way on or all the way off. I'd like you to pause the video here, and I want you to think about how would I change a value on a particular circuit. So for example, if I wanted to make the R to be 128, what would I do electrically at pin R in order to make that happen? So pause the video and think about that, and then I will reveal the answer after you pause. Well, hopefully you really did pause the video and think about how I can make the R pin to represent a 128. And so what should have come to mind is pulse width modulation, right? We're talking about the duty cycle of this particular circuit. So if I pull up our duty cycle that we previously created, and I'm going to change the values instead of 0 volts and 3.3 volts in this case, although we really are using 5 volts. That doesn't really matter, right? So I'm going to do 0 volts. I'm going to change that to the value of 0. And the 3.3 volts, I'm going to change that to the value of 255. So if I wanted to get in the middle, which 128 is in the very middle, I would need to produce a signal with a 50% duty cycle. Now we've already proved out that we would have to increase the frequency. It'd probably need to be around 100 hertz, but with a 100 hertz frequency at a 50% duty cycle, I could make pin R represent a value of 128. Let's change our voltage back to the value 0 volts for off and 5 volts for on. So a 50% duty cycle, 100 hertz frequency signal would put us at an average of 2.5 volts right in the middle of our pulse width modulated signal. So that 2.5 volts would translate to an R value of approximately 128. So in order to program this LED to have pulse width modulation, we need to connect the R, G, and B pins to a pin that can do pulse width modulation. So it's a little different than when we did the LED. On the LED, we use the high side to pulse width modulate the signal. Now we are using the low side, or the ground side, to pulse width modulate the signal. Either way, it will work to change the average voltage that we would read on a multimeter, and thereby giving us different colors. So in order to set this up, we will be connecting the pins in the following way. So the VCC, which is the brown pin, will go to our 5 volts. And then the R pin, which is the white wire, will go to the GPIO 17, which is physical pin number 11. And the red wire, which is the G pin, will connect to physical pin number 12, which is GPIO pin 18. And finally, we will connect the black wire, which is the B pin. We will connect it to GPIO 27, which is physical pin 13. This setup will allow us to pulse width modulate either the R, G, or B in a combination that allows us to change the color of the LED.